Okay, in this video, I'm going to go over the odd periods practice sheet we did in class today in preparation for the quiz next class. Now, you also need to know other things beside this, and I put it all on the board. So you definitely need to know about synthetic division. That's one thing that's not on here. So make sure you can do this. So you've had a couple of practice opportunities. You want to go over all of them and make sure that you have a good handle on the material for the beginning of chapter 3. Okay, so let's go over these. So they are giving you a polynomial and it's in factored form. So they want you to sketch the graph of each of these. Your graph should show all the x-intercepts with appropriate multiplicity shapes, along with an accurate y-intercept and correct end behavior. Okay, so the sketch is going to show you the correct end behavior. I also wrote this out as end behavior so that you are able to correctly indicate what it is. Okay, I talked about for the quiz, if I just give you this without a picture, so just this function without a picture, are you able to tell me that it's a cubic and the end behavior is going to be as x goes to negative infinity, y goes to negative infinity, and as x goes to positive infinity, y goes to positive infinity? Make sure you can do that. Okay, let's go over some of these things. Okay, to find the roots, also known as the x-intercepts, set each of these factors equal to 0 and solve for x. Now, key thing, anything with an x is a factor. So this is a factor, this is a factor, this is a factor. Here are my roots based on setting these three factors equal to 0. So I have a root of 0, a root of 3, and a root of negative 2. Because there are no powers written here, it's all power of 1, and therefore the multiplicity is indeed 1 for all three roots. So here are my roots. Here's the negative 2, here's the 0, here is the positive 3. The degree of this is a cubic because if you add up all your exponents, or if you multiply this out so that you have a standard form, you'll be able to see that x cubed is your leading coefficient. Okay, the y-intercept, that's a point of confusion for many of you. So when you get the roots or the x-intercepts, you do that by setting each factor equal to to 0. To get the y-intercept, you set each x equal to 0, and you then multiply the resultant number. So let's do this. If this is 0, I have 0 times, if this is 0, this is negative 3, and then times, if this is 0, 2. Well, 0 times anything is going to be 0, and that's why this root also functions as the y-intercept. Here's your shape. Since it's a cubic, it's an odd function, and since this is a positive leading coefficient, the direction is down up, and this is how you would actually write your end behavior. Okay, going on to 20. Looking at this, I see I have another cubic. My roots are attained by setting each factor to 0. So my root is positive 3, negative 2, and then set this equal to 0, and you get 2/3. The multiplicity for each of these three roots in the cubic is 1. Here is negative 2. Here is 2/3. Okay, here's 1, so 2/3 is a little bit to the left. Here is 3. Those are my roots. Okay, let's get and the degree clearly is 3. Let's get the y-intercept. If I plug in a 0 here, what will I get? Plugging in a 0 gives me a negative 3. Plugging in a 0 gives me a positive 2. So far I have a negative 6. Plugging in a 0 here gives me a negative 2. So I have negative 6 times a negative 2 is a positive 12, and that's why that is my y-intercept. It's a cubic with a positive leading coefficient. So you start out going down and you finish out going up. And here's how you would write out that end behavior. Okay, let's continue on to the next problems, which are 22 and 26. Okay, so look at this one. This x outside is going to make my y-intercept and my first root, I guess it is, equal to 0. Okay, to get your roots, set each of these to 0. Set each of the factors to 0 and solve. So here's 0, -1, +1. Ooh, look at this guy. 2 minus x equal to 0 is 2. Now, look at the leading coefficient. To get the leading coefficient, you multiply the x's and their signs. Positive, positive, positive. Ooh, negative. The leading coefficient is negative. For an even power, because this is 1, 2, 3, 4, my direction of the graph will be both heading down. Here's the proper way to write that in terms of the end behavior. Understand why it's going down. Okay, and if you're going to figure out what your y-intercept is, it's really easy. If you have an x out here and you set that x to 0, the whole shooting match becomes 0. And therefore the y-intercept is also a root. Okay, now a little word about this. What I did is I wanted to see in between the roots, how high did my function go? I plugged in a 1/2 for each of the x's and I solved for it just to get a sense of where my function would go. Now, you don't need to do that, but if you're in a more advanced math class, you will need to do that. So I thought I would just do it for you so you have a sense of how high and low the maximums and minimums actually go in the functions that we're analyzing. Okay, that takes us to 26. 26, look at that. I have a negative leading coefficient because of that negative. I have a 2, 3, 4, 5, 6. It's an even degree, but because I have a negative leading coefficient, my ends are both heading down. I wrote out my end behavior for you. Let me just slide this up a little bit so you can see it. There you go. So you can see the end behavior now. You should be able to write that. Okay, the roots. This root set equal to 0 and solve is a -1 with a multiplicity of 2. This is a 1 with a multiplicity of 3, and this is a 2 with a multiplicity of 1. All right, how do I get my y-intercept? Plug in a 0 here. You have a negative in front, so this is becoming a 1 squared, which is still a 1, so I have a -1. This becomes a -1 cubed, which is still a -1. So far I have -1 times another -1, which is a +1. This becomes a -2, and a +1 times a -2 gives me a y-intercept of -2, and there you have it. Okay, so you have a double root here. This is a triple root. Notice how it kind of hangs on the x-axis and then proceeds up and through. Here's a single. So be able to mimic that in a testing situation. Okay, so how are 32 and 36 different than the previous problems we just reviewed? Well, these are not factored. So your first job to be able to analyze your roots is to go ahead and factor it. So I factored out the x because I did greatest common factor factoring. That leaves me with x squared plus 2x minus 8. This is an easy factoring. What multiplies to -x and adds to 2. And the answers would be 4 and -2. Those are what I put into my factors. That provides me with roots of 0, -4, +2, each with a multiplicity of 1. So here are those 3 roots. The function passes right through it because the multiplicity is indeed 1. This is an odd degree, and the leading coefficient is positive. So therefore, I start out going down, end up going up. Here's how you would write out the end behavior. And to get the y-intercept, remember, if you have an x out here in front and you set that x to 0, it makes everything 0. Since they gave it to you as a standard form polynomial, do you have a constant? You don't. Therefore, your constant is 0. And remember, your constant is always the y-intercept. Done. So in two different interpretations, we're able to get the y-intercept, and here's a nice graph. Okay, 36, same idea. This is in standard form. Notice that the constant is a 0. Therefore, the y-intercept is a 0. Factor out an x cubed. You're left with the difference of perfect squares. Here's fully factored form. And what I'm seeing here is that here's a factor with the x's in it, right here. Set that equal to 0, you get a 0. Set this equal to 0, you get a 3. Set this equal to 0, you get a negative 3. If you want to get the y-intercept at this point, and you set all your x's to 0, this will all go to 0. If you want to look back up in your original form, you see you have no constant term, therefore your constant term is 0, and your constant term is indeed the y-intercept. So here's your end behavior written out appropriately. The degree is 5, and we are done. Okay, let's come on down. Okay, so here's a little word problem. I'm looking for a 7th degree polynomial. That means when you add up all your powers, it has to be 7. And it has to have a positive leading coefficient. Therefore, this is a positive, and both of these, all the factors are written in the traditional way. So here, why is this degree 7? 2, 3, 4, 5, 6, 7, bingo, positive leading coefficient. 1, 2, 3, 4, 5, 6, 7, also bingo. There are many other answers possible. So you should not have my answers. It would be a miracle if you showed up with all my answers. Okay, miracles happen, but not generally in my math class. Okay, a 6th degree polynomial has a negative leading coefficient. The easiest way to do that is to put the negative right in front. 6 degrees means that when you add up the exponents, you get 6. 3, 4, 5, and 6. Ooh, 5 and 1 makes 6. As I said, other answers are possible. Miracles happen, but not with this. Okay, then you have matching. So we talked in great detail in class about how you're going to strategize with this. Okay, here's your strategy. Let me just make this a little bit smaller. Okay, looking at this, what I did first was I figured out the degree. 2, 3, 4, 5, 6. This is degree 6. 3, 4, 5, 6. This is degree 6. 3, 6, 7, degree 7. 2, 1, so 2, 4, 5, degree 5. Okay, so what I'm seeing is this is going to be an even degree. It's going to have a positive leading coefficient. So therefore, the arms are both going in the same way, and they're both going up. I know that A and B have to be here, okay, because those are the only even degrees. So let's look at this one. This tells me I have a triple root at positive 1. That's a triple root. That has to go with A. If this goes with A, this has to go with B. Go down here. Looking here, I see that I have an odd degree with a positive leading coefficient. So my arms are going to go down and up, down and up. Okay, so let's see what we have. Look what I have here. At x is 3, I have a triple root. Bingo. Triple root, only a double root. This is C, this is D. We are done. So this is not sufficient to be able to do well on this quiz. You have to know synthetic division, go back over the previous homeworks and the previous notes, and you will be set for this coming assessment.